Hi everyone, welcome to the fourth class of SQL Server. So what we have learned so far, I'm just going to revise and after that we'll go forward and we'll go with the creation of database. That means we'll talk about how do we create a database in SQL Server. So first of all, we started with the term data that we started and we learned what is data. Then we talked about database. We talked about the database management system. After that, we talked about the different type of recovery models that are there. We also talked about different type of relationships that are there, like one-to-one, one-to-many. We created ER, like we saw that how the ER diagrams are created, like how the relationships are there between different type of tables and other objects. Also, we learned about what is file group, and all of that. Other than that, also we learned about what are the different types of commands are there, like DQL command, DML command, DDL command, DCL command, and what are the things that would come inside those. Now, the next thing that we want to learn about is that we want to do some practice now. That means we have definitely learned some concept, but everything is all about practice in terms of database. So the first thing that we are going to do is that we are going to create a database where we'll be doing our practice. So when we talk about the database creation, we have already learned that what is Microsoft SQL Server. It's a relational database management system. Always the term relation is coming. Why? Because when we when we talk about any such system where we have tables and other things, what we see is that we establish some relationship between these tables, and that's where it comes hand in whenever we want to write the queries and all. This relationship is what becomes important because through that relationship you can join multiple tables and all, right? So let's see how do we create a database, right? So there are multiple ways of creating the database. You can see that this is a management studio, right? I hope that you guys have installed it already. I've sent the link for you to install. So there are multiple ways of creating the database. First is that you just click on that database folder and you right click there, and there you see the option of new database. Once you click on new database, then you need to enter the name of the database. For example, bash 266. This is the database I want to create. As I had told you earlier as well, whenever you want to create the database, it will have by default a minimum of two files. One is the data file and second is the log file, right? So the first file that is here getting created, it's the data file, and second is the log file, right? And then if you see the path also, both are getting created in the same path, right? The only difference is that the first one is the data file and second is the log file, right? So this is one way of creating a database. The other way is the query way, which actually I like better because again, through the query, it's actually easier. And also in a system where you are doing lot of stuff, other stuffs as well, it's better to go through the queries with method, because again through queries you can do everything. So it's better to do that rather than just following up some infra related things like right clicking of folder and things like that. That will not raise up the confidence. The thing that will raise up the confidence here is to do the queries and all. So for creating the database, again, there can be many type of queries. We'll go with the basic one, right? So the basic query here is that create, then database, and then name of the database. So we want to create a database with the name bash 263. That's all you need to write, right? And once you write that, maybe to just say that this is the end of my statement. Now this is optional. Either you can put the semicolon or you can just leave it like that. Both way it will run fine. The semicolon that I put here is not mandatory, right? So let me now execute it. Once I executed, you saw that I got the message that command completed successfully. But as of now, do you see this database here in the database tab? No, it's not there, right? So why it's not there? Because whenever you create something, after that you need to refresh that tab, refresh that view so that that comes in the view. So now I'll just right click here and click on refresh. Once I click on refresh, what you can see here, we can see that we have that database created here, right? And right now that database is empty. That means it doesn't have anything. So we have just created a database with the name bash266 and it's empty right now, right? And when we created the database, if you see, two files by default got created. One is the primary data file and second is the log file. It all got created in the file group primary, which is the default file group, right? If you go to the option to check what is the recovery model, you will see that the recovery model of this database is full. But I don't want it to be full. I'll want to change it to simple. You know the reason and all, right? And I'll click on OK. Now the recovery model of this database is changed to simple recovery model. You can change that through the script as well. But again, I am showing different ways of doing the same thing, and that's why I did do that. Now, what we are going to learn here is that through the SSMS thing, which I have already shown you, so I can skip. Now, what is the limitation and restriction of creating the databases in SQL Server? So one of the limitation is that a maximum of 32,767 databases can be specified on an instance of SQL Server. What does it mean? It means that on a single instance, on a single server, you can create a maximum of 32,767 databases. This is the maximum database you can create on a single server, right? So, but I think this limit is a lot, right? No one is going to create that many databases on a single instance. So this is, but this is the maximum number of databases that can be created. This may be asked sometime in interviews and all. So from that perspective, you can try to remember. What are the prerequisites? One of the major prerequisites is that the create database statement must run in auto commit mode and is not allowed in an explicit or implicit transaction. We'll talk about the different type of transaction maybe after 10th class or so, right? But as of now, just understand that whenever you write the create database statement, right? So that should be the first statement in that row. That means you should not be writing any other statement before the create database statement. So this is what you can say that means by this particular statement. As of now, just forget whatever the auto commit mode and the implicit transaction or the explicit transaction. We'll talk about that in detail later on. But just for sake of simplicity, what you can learn from here is that the create database statement should be the first statement that should be there in that particular query session whenever you are trying to create a database. Again, in a normal scenario, not everyone can create the database, right? So that requires a specific permission like create any database or alter any database permission, right? So here we are talking about the permission to a user. So for example, you go in a company and your manager asks you to create a database in the development environment. But when you are trying, you are not able to create that database. What may be the reason? The reason is that you may not have the permission to create the database. So in that case, your manager could ask, maybe he's from the non-technical background, so he may ask that what are the permissions that are required, right? So in that case, you will say that, okay, I need two permissions. One is the uh, create any database and second is the alter any database permission. Now, again, let's revise whatever we have learned so far. The reason why I revise things 3-4 times again is that if you're not able to pick up from the first time, from the second time, maybe because if you'll revise it 3-4 times, you'll be able to pick that up. In that same scenario, I'm just going to again revise one of the things that we have covered already 2-3 times is about the data files and the log files. So every database has at least two files. One is the primary data file and second is the transaction log file. The primary data file that actually has the suffix .mdf. The secondary data file, it has the suffix .ndf. while the log file, it has the suffix .ldf. Now this is the default nature of all this. This can be changed definitely, right? So this is not something like a hard and fast rule, but just for the sake of simplicity or the sake of uniformity, we keep it like that. Although OS file name can be any valid operating system file name, the name more clearly reflects the purpose of the file if you are using the following recommended extension. That means you can just use any extension or any suffix here, but again, this is more about just using or following the recommended extensions or things like that. Now, in a different way, this is how complex this can go. The create database statement. Right now, you saw that we created the database just by using create database and database name, right? But it can, what you can do is that you can just write other things as well. For example, you can give the name of the primary file, primary data file, the secondary data file, and also the size and the other things. All those things are actually coming from here. If you right click on the database, right, as of now, if you show the go into the properties and go into the files, you see that there are a lot of properties here, like what is the current size of the database, what is the auto growth or maximum size of the database, what is the path and all. So all these things are configurable, right? And you can actually change that. So these things, while creating the database, you can actually give all this path, all this size of the database, and how it should increase and all of that. So that is what coming into picture here. But again, normally as a SQL Server developer, it would be very rare for you to create the databases, because when we work the system in a system, these databases are actually already created by the IT team. So there's another team which is different from the developer team, who is responsible for the infrastructure and all. So they mostly create the databases or the other stuff. The only thing that you want to know here is that, again, from your perspective as well, that what are the different options that can be there and how to manipulate them, right? So that's the purpose of training you about all this. Now, the other term that I wanted to cover today is about the database objects. Like, what are the different objects that are there? Anyone has any questions so far? Okay. So let's talk about the different objects that we are going to cover now, right? Once, as we have now created our database, right? The next thing that we want to do is that we want to create different type of objects in that database. So these are the different type of objects that we are going to create in the first few days now, which is about tables, data types, function, index, constants, store procedures, triggers, views. So these are the different types of objects that are there in SQL Server. But again, there can be other objects as well, like we can have table variables, temporary tables, CTs, and other things as well. But as of now, we are going to focus on all these objects that I've mentioned here. Like we'll talk about what is table, what is data type, what is function, what is index, what is constant, what is store procedure, what is trigger, what is view, right? So we are going to talk about all of that. Let's talk about table first. SQL Server database stores information in a two-dimensional object of rows and columns called table. In table, we have two type of things. One is the column and second is the row, right? In the context of a relational database, a, a column is a set of data values of a particular simple time. So column is also known as attribute, right? So in the same way that we say table entity, the column can be known as the attribute and the rows can be known as tuples. In the context of a relational database, a row, also called a record, represents a single implicitly structured data item in a table. So let me just show you an example by just getting out the column from here. Now we have this adventure work database, right? Suppose that I just want to get some value from this particular table, right? So as you can see, the query that I have run here is that I've selected columns from this table name AdventureWorks 2019.humanresources.employee, right? This is known as the dot notation. Right now, the focus is not there. We'll talk about that later on. Right now, just let's try to understand what is the column here, what is the row, right? So the above thing that you are seeing here, like the business entity ID, right? That is a column. This national ID and number, that is a column. This login ID, that is a column, right? Then what is a row? Row is like this. Now this is the first row. This is the second row. So a row contains the value from all the columns, right? In a column, we'll talk about just one property. So that's why a column is also known as attribute. And this is known as the tuple, right? And then when we talk about the table, that is known as the entity. So entity has attributes, right? And then it has tuples as well. When we talk about tuples, we are talking about rows, right? Different rows. These are the different rows. When we are talking about attributes, we are talking about columns. Now, let's also, since we are talking about this basic select query, let's talk about the query here. I'll just remove this top 1000 because it may get confusing for you. I'll just take the, so this query can actually be written in multiple ways and it would produce the same result. For example, the same query, I can write it like select star from human resources.employee, right? And that will also give me the same result. I can just show you that. You can see that I got 290 rows here. How do I know that there are 290 rows? If you just focus on the right hand bottom side of the screen, you can see a lot of information there. The last information there is the number of rows. I have already put my cursor over there, right? So you can see where I have put the cursor. There the number of rows is written like 290 rows, right? So in the same way, if I execute the above query, I get the same number of columns like that we have here. Like you can see that we have in the end row GUID and the modified date. In the same way, if I run this one, I'll get in the end the row GUID and the modified date. And again, it has the same number of rows as well, right? So these both queries are same in terms of their result set. But there is a difference in how we have written the queries. Now, I have a question here. I just want to understand. If you don't know, that is also fine. But I just want to understand that if anyone knows in a normal scenario, which query would be better? Maybe right now they are giving the same result, but when you are going for writing the queries, which way you should follow? Which way should you write the queries and all? The first way, the top way, or the bottom way?
The top way.
And why
Second
so?
last. Sorry.
Okay. So whoever said the top way, I just wanted to understand why you said top way.
because
Why do you
all the
think?
because
Mhm.
all the entities are defined here, and I don't think there'll be a mix-up. The second one that you did, I'm not sure. Does
Okay.
everything, all the functions will run properly?
Perfect
Yeah.
answer. Perfect answer. So that is what the correct thing here, right? Whenever, see, right now we are just dealing with one single table here. What if we are going in future and we are talking about 10 tables, 20 tables? Because in the real environment, there will not be a single table, right? And also, even if there's a single table, what if I just want to bring out just 5 columns out of all the columns that we have? For example, it's very easy to do that change here. I can just remove this column. Suppose that I just want to get this columns from this table, right? So I can just run this query now, and this will work totally fine. In the select star, it will always bring up all the columns. So even if I don't want something like that, I'll have to get it. There's though no way to restrict that without giving the name of the column, right? So it's always better to write this query. Now the only thing is that other thing is that there are sometimes we write cross database queries as well. What is the cross database queries? Like the queries in which you are using multiple databases together, right? So in that case, you might want to put the database name as well, just to tell that okay, this table is coming from this database, right? But in the normal scenario, when you are not using cross database queries, this is optional, and you can definitely ignore this one. And this is what would become the perfect example of how we'd be writing queries and all in the future, right? So we'd be using the schema name dot the table name. As of now, we have not talked about the schema in detail, but we'll talk about it later on. Now let's talk about the data type. Data type specify the type of data that can be stored in a column. Data type are used to apply data integrity to the column. SQL Server supports many data types like character, varchar, integer, binary, decimal, money. You can also create your own data type, user-defined data type using the system data type, right? So data type is one of the important things in SQL Server because everything that we are doing here, that is about data, right? And then we also need to mention that what is the type of data that we want to use for doing anything. And with data, there comes a data integrity constant as well, right? So that's where, for example, suppose that you want to write, you want to store the salary, right, of an employee, right? Now the salary can be stored in many ways, right? But what should be the appropriate data type for the salary? So in SQL Server, we have a data type named as money, right? Because salary, we are talking about something related to money, so it's better to store it in money, right? So this is how, whenever we are creating a tables and all, we'll soon create a table by ourselves, right? So at that point of time, we'll see that whenever we are defining the column, we are giving it a data type of each of the column, right? And that way SQL Server will make sure that you enter that particular type of value, whatever you have given the description of the data type for a particular column. For example, once I give salary money, and then I want to store the value Anup in the salary, SQL Server will not allow. SQL Server will say that this is not matching to what a money would look like, because money is something like maybe I can write 101.24, something like that. That is a valid money thing, right? But this is not a valid money thing, right? So with data type, we actually control, or we try to make sure that there's data integrity in the column or the tables or whatever we are doing. So the popular data types that we use, so we have char, we have varchar, we have integer, we have binary, we have decimal, and we have money, etc. Now you must be actually thinking, if you don't know, that I just talked about character and varchar. What is varchar? Because this may be looking like new to you if we are not having any background in SQL Server. So we'll talk about that difference as well just soon. But as of now, just understand that there are different type of data types. And the usage of data type is to make sure that there is data integrity in the columns and the overall object, that is the table and all, right? So I just explained that with data type, we are restricting the type of data that can be stored inside a table. Now let's talk about the other object, which is the function. Microsoft SQL Server allows you to create functions. These functions are known as user-defined functions. It represents business logic using one or more transact SQL statement. It can accept parameter and can return scalar data value or a table data type. It can be used in the SQL statement, which is added advantage over the store procedure, right? So there are different type of objects. We are just talking about function. We'll soon talk about the store procedures as well, right? So again, because we have the flexibility, but we should also understand that in which scenario we should be using the functions, in which scenario we should be using the store procedures. One of the major difference between the store procedure and the function is that when we talk about functions are of multiple types. We have the scalar functions, which actually return just one single value. Then we have table valued function, which returns data in the form of table, right? One of the good thing about function is that you can use function inside the select statement. You can't use the store procedures inside the select statement. Why there's like that? Because functions return a value always, whether it's a scalar function, then it will return one value. When it is table valued function, it will return something in the form of table, but it will always return a value, right? So that is the major difference between the functions and the store procedure. So but store procedures has its other advantages, which we'll talk about. That will also, when we'll talk in detail, then you'll be able to understand, okay, these are the differences between the functions and store procedure. The purpose of this particular session is just to give you introduction to the term. So now you know that there are objects like tables, there are data types of those columns that we define. Then we have functions. After that, we have indexes as well. Now, what is the index, right? So index can be thought as an index of the book that is used for fast retrieval of information. The best way to understand an index is that, suppose that if I don't know how many of you have used dictionary in the past, right? Dictionary is something that we were using in the past just to go through, find any word, right, and then find the meaning of that word. That is what we were using. Oxford Dictionary is one of the famous one that we were using, right? So for example, how do you go through the dictionary? What is the way to search for things in the dictionary? You go to the index page, right? There you search for that particular word. Then whatever pattern that you find the page number associated with that pattern. Then you go over to that page number, and there you just again search for that word and you find it, right? But if you don't have the index page in the dictionary, what will happen in that case? You'll have to just go and search one by one for into each of the pages, and it may take hours to get that particular word that you are looking for, which otherwise with the help of index you were able to get in just maybe seconds or minutes, right? So that in the same way, like we have index in the dictionary, in the same way we have indexes in the databases as well. The purpose here is also the same. Using the indexes, you want to retrieve the information faster. So indexes are used just for the select statement. Whenever we use the select statement, in that case only you can use the indexes, right? So indexes can be thought as index of a book that is used for fast retrieval of information. Indexes uses one or more column index keys and pointers to the record to locate record. Indexes are used to speed up query performance. Kind of the indexes are clustered and non-clustered. So there are two kind of indexes. One is the cluster index and second is the non-cluster index. We'll talk in detail about indexes, both of the type and then other types as well. And what is the difference? What is the definition difference between the clustered and non-clustered index, and which index is better? While there is a term here, the third point, that point is not always true. Like it's written here is that index is used to speed up query performance. That is actually, you can say that that is half correct statement. How I would actually say that better indexes are used to speed up query performance, because again, if you create bad indexes or if you create lot of indexes which is not useful, that will actually decrease the query performance overall. It will not increase the query performance, but it will decrease the query performance. So that's why whenever you are creating indexes, you have to be very careful about what type of indexes you are creating, right? And whether that is useful or not. So we'll talk about all that in the indexes session. Next is the constraint. In using constraint, SQL Server enforces the integrity to the database. It defines the rules that restrict unwanted data to the database. Constant can be table constant or column constant. So there are various type of constraints in SQL Server. Some of them are actually apply over the whole table, while some of them apply over the columns only, right? So that's why we are saying that there are multiple type of constraints. Some of them are table constant and some of them are a column constant. Like one of the example of the constant is that, for example, I say that salary is type money, and again I say that not null. This is how mostly we define a column whenever we are trying to define a table, right? So by not null, what you're trying to say is that this particular column can't accept null values, right? So that is a type of constant here. This is a not null constant, and this is the column level constant, right? That is applying over a column, that this column can't accept any null values. So this way there can be other constant as well. I just gave you example of how do we define constant, and some of the constant we define it on the table, some of them we define on the column level, right? So let's go further. Let's talk about other objects. We'll again come back to this topic soon, and we'll talk about that in detail. Now talking about the constants, we have this major constant that we have in SQL Server are the primary key constant, right? Whenever we define a table, we define one primary key on the table. There cannot be more than one primary key in a table, and there is a particular reason for that. We'll talk about that also when we'll create the tables and all, right? Then we have the foreign key constant, which actually takes care about the relationship. It relates two tables in the form of parent and child. Then we have the unique key constant, and we have the check key constant. These are the major constants. Other than that, also there are different type of constant. We'll talk about those as well in detail. We'll talk about so how to create this constant, what is the meaning of this constant, how to drop this constant, and what is the purpose of each one of this. Then we have the store procedure. The store procedure is something which is used to encapsulate the business logic, right? If you have some complex business logic, if that is something that can be done easily, right, then in that case what you do is that uh, you just uh, uh, you just go through and you'll use the already defined objects of SQL Server. But it is something that can't be done using the already defined objects in SQL Server. In that case, you'll define the store procedure. So what is a store procedure? A store procedure is a compiled set of transact SQL statement. The business logic can be encapsulated using a store procedure. It improves network traffic by running set of transact statements in one go. As of now, maybe the third line is not making would not be making more sense to you, but we'll talk about that again with a different diagram. I'll tell you at that place that why we are saying that it improves network traffic. What is the difference when we execute a statement inside the store procedure and when we execute a statement without the store procedure? So we'll talk about those things as well, right? But as of now, just understand that the store procedure is one of the most usable objects in SQL Server, and any complex business logic or anything like that, you create it through the store procedure, which can't be done by other objects because everything has a limitation. But again, store procedure actually has only few limitation. One of the limitation is that you can't use it inside the select statement. Other than that, you can do almost everything using a store procedure. Then comes the trigger. Trigger is a special type of a store procedure, right? So trigger, you can say that trigger is a store procedure only. The only difference between trigger and store procedure is that trigger is event driven. That means trigger is fired automatically, while the store procedure you execute it manually, right? But the triggers, they are actually defined on some condition. For example, suppose that you have defined a trigger that whenever the records are inserted in the employee table, then this trigger should be fired. So in that scenario, you'd use a trigger, and that is why the trigger is known as the event driven store procedure. That means you have defined it on the insert statement here, and the trigger would be fired in case that insert statement runs. It gets initiated whenever the insert, delete, or update event occurs. It can be used to maintain differential integrity. A trigger can call a store procedure. So inside the trigger, you can call store procedures as well. Similarly, in the store procedure, also you can call different store procedures. And the trigger is used to maintain differential integrity. That means, for example, if some record is getting inserted into one table, Then what you can do, you can define a trigger on the insertion of that record in that table, and inside the trigger you can write logic that whenever that record is getting inserted into that table, insert record in some other table. So that way you can put up some referential integrity. So that is the purpose of trigger. Last but not the least is the view. View can be created to retrieve data from one or more tables. Query used to create view can include other views of the database. So view is nothing but it's like just adding a level of encapsulation on the tables. You can say that the view is like that. So view can either be defined on just one table, or you can create views on multiple tables as well. Like you can join multiple tables and you can create view on top of that. So both way it is possible. But why do we need view? I'll tell you a classic example in which scenario you use views and all, right? For example, there are, suppose that 100 columns in this table, right? And you just want to, you just use out of 5 7 columns of those 100 columns all the time in different queries. So instead of using those 100 columns, what you can do, you can create a view with this select statement, right? And then you can use the view, that view, instead of using that select statement directly from the table, right? So that way it would make your job easier and all, because now you have this, in this table you have 100 columns, but you just use this 5 columns. So better to create a view. So that is the purpose of view. Through view you can just, you can say that you can change the definition of the objects, or you can just use what you want instead of using all the columns in the tables. Also suppose that there is some, there are two table joins that you are using all the time, right? And what you can do is that if you are using those queries in all the different conditions and all, so instead of using that those as this table queries, you can create a view on top of that and you can just use that views. That way also you'll have to write less line of codes, right? So view also increases simplicity of the code as well. That means right now if you are writing 20 lines of code, maybe that will be get converted into just one line of code, right? So that is one of the purpose of the view. Now the next part of this is that we'll create a very basic table, right? This is the next thing that we want to do. We have created a database today, which is the batch 263. I want you to do the same thing using that simple statement that I used, create database. Once you create the database, the next thing I want you to do is that you can create a basic table. As of now, I'll not talk about the primary keys, foreign keys, etc. I'll just create a very basic table. So for creating a table, the syntax is like that: create table, then name of the table. I'll say class 4, right? And then you start the brackets. Then I'll say that student name, and then the data type of the student name. So I will give it a data type varchar. Now I'll also explain, because I'm using this varchar now. So it's better that I'll tell you the difference between the char and the varchar, right? So let me just quickly write the column names and all. Let me define this table. After that, I'll explain you what is a varchar and in which scenario you should be using the varchar, and in which scenario you should be using char. And then maybe gender, I'll use char1. That way I can define. Then age, a small int, then marks, and I think that is sufficient. So I've just created a table, right? It doesn't have any primary key or other constant. I've just kept it simple as of now. The first column I have defined is the student name. It's of the type varchar 30. The second column is the gender, which is of the char1. Because gender, I'm going to just write mf, just one single single word. That's why I've kept it the size 1. Then the age I've kept it as a small int, and then I have the marks. So that I've kept it, or maybe the, let's keep it fees. It's of the type integer or the int, right? These are the four columns that I've kept in this table. If I'll click on execute, now this command, it completed successfully message we have got. So if I just run this, select a star from this table name, you will see that this table has been created, right? And it has all these four columns. Now, before going to that definition that I want to give, I just wanted to understand if anyone from class knows that why I have kept the, like, for the student name I've kept varchar, while for the gender I've kept char. Anyone knows why it is like that? And also the other thing I want to know is that why age I've kept like a small int, why the fees I've kept like int. Any idea anyone has? Okay.
Probably to wildcare can have space in between if needed.
Mm-hmm. Okay.
Like if
Yeah.
it's a
Yeah.
first, I'm guessing if it's a first name space last name.
Yeah, I
Where
just
can
want to, yeah, that's good try, Chris. Definitely, I want to know. The only reason of asking this question is that I want to understand the. So it's not like that if you will answer wrong or something like that. I'm not going to deduct any marks or something like that. It's just that let's guess and let's try to find out that how logical we are and those stuff. So those are, that's the only reason of asking this question. So that is a good try, Chris. But again, this is not correct. I'll again come back to what is actually the reason why we have given. But I just wanted to know anyone else also wants to answer this one. That why there's, why we have kept that as char one and char one. So just to answer your part, what you guessed. So basically, in the char or in the varchar, both can accommodate spaces and all. So you can keep spaces
okay.
in both of them. So let me come to the point now. Let me talk about the main differences between the varchar and char, right? So both are character type of data. So that is one similarity between them. So both can accept characters, right? So now whenever you define varchar or char, you have to give a size, right? So that is the most important thing here. So if you see for the gender, I have kept the size to be 1. So when you give the 1, that is what you give as the maximum size. That means for the gender, if you are going to insert something like male or female, SQL Server will throw an error. SQL Server will say that you have kept the maximum size of this to be 1. So that's why you have to just insert 1 size as the maximum for this column. In the same way, if you define something as varchar, in that scenario also you have to give the maximum size. So for the student name, it can accept up to 30 characters. If you give something more than 30, SQL Server will throw an error, right? So as I said that in both the cases, again, this is the similarity between varchar and char. You need to give some size and of both of them, like the varchar and char, and then that is the maximum size. That means SQL Server won't allow you to enter something more than that. Now let's come on to the actual part, actual difference between varchar and char. So one of the major differences between varchar and char is that when you define char, right, SQL Server will reserve the space for that particular, whenever you are inserting data into this column, SQL Server will reserve the space for this at the time of compile time. While for the varchar, SQL Server reserves the space at the time of runtime. So that's the major difference between the varchar and char. So for char, the SQL Server will reserve the space at the time of compile time, and this will, it will do in at the time of runtime. Now there is another difference here. Now compile time, runtime, maybe it will get confusing. So let me tell you the major thing here. For example, as of now, this is char1, right? This is varchar 30, right? Suppose that you have inserted few names only, like Anu, Ajay. So these are some of the student names that you have inserted, right? So you can see the number of characters for this is just 4, while you have defined this 30 as the maximum. So when this is 4 only, you are using just 4 spaces for the student name instead of using 30 spaces. SQL Server, because it allocates for the varchar the space during the runtime, it will just allocate 4 bits for this. It's all about storage here. While if suppose that it has been char 30, suppose that I had kept this column like char 30 instead of varchar, what would happen? SQL Server would always put 30 bits, even if you are storing something like Anoop, something like Ajay, or something like A, which is just one character. In that case, also SQL Server will actually allocate 30 bits. So it's like, because it's a storage waste, right? Suppose that if we have column, like suppose that this is varchar 300 and you are using something like 4, you can see that if I'd use char here, that it will be a huge storage wastage here, because you are just occupying 4 bits while you have actually defined something like 300, right? So that's why if you are not sure about the size of the data that you put for a particular column, always define that as varchar. Any column for which you are not sure about the storage size, right? What would be the actual size of the data that you'd be getting, that is varying, always keep it like that. Something which is small and something which is fixed, for that you can use char, because this is static type of data. That means the space is always reserved to be whatever the size of the data. That means if it's 1, then 1 would be reserved for all the columns or the gender rows. If it is 10, 10 bits should be stored, or it would be reserved in advance for all of this. While this is varying character, the name of varchar is actually varying character, while this is just character, right? So here the space is allocated at runtime, and at that time SQL Server sees that how many characters you are trying to insert. So even if it's 3000, but if you are just using 4 bits, only 4 bits would be reserved, right? So you can see that you are getting huge benefit in terms of storage size. So that's why in most of the places we'll use varchar rather than char, because storage is one of the keys area. So whenever we talk about, or whenever we design our objects, there are two important things. One is the storage, and second is the IO. And whenever we design any object, we actually compare it everything by this way, right? Now in the same way, we have the age as a small int while the fees as int, right? Why I kept like that? Why I've designed my table like that? Let's try to understand that as well. So age is a small int because what can be the maximum age of a particular person? Maybe he can go up to 200 years, at max 250 years. It can't go to 10,000, right? Your age can't be 10,000. It can't go to 1,000 also, right? And that's why I have kept it like a small int, because inside the small int, you can actually cover all the ages that a human can be. That's why I've kept it like a small int. Now, when we talk about the fees can be anything. Like it can be $100,000 as well. It can be more than $1 million as well, right? So just to accommodate that, I've kept it like int, because int would take more bits in terms of storage than the small int. So always, whenever you are defining your objects, always use appropriate data type. But it doesn't mean like that just keep it something like, for example, a student name, just keep it 10 because you know that some of the students are 10. That is not a good approach. Try to keep it something like that which is actually genuine in the uh, terms of when you are defining things. Most of the things are actually already analyzed, and when you get the requirement, you also see that okay, this would be the size of this particular data type, and that would make your life simpler But if you have to make that decision yourself, then you have to do the proper analysis of data, and that's how you have to define the each of the data type column, right? So as of now, I've just created this table, right? If you want to drop this table, then you can just write the drop table statement for that. So if you want to drop the table, you can write drop table table name. We are again going to learn all that in the particular table classes, but the purpose here was to just give you some basic overview of the things that goes inside. And also these things are not basic anymore, because again these are actually making you to make a decision about the storage space and other things. Any questions on this thing? Anyone has? Okay, so now we'll have another topic after this. The next thing that we want to learn about is that we want to talk about the different type of constraints, and then after that we'll want to go about the different type of data types in SQL Server. That is what we'll learning next. And when we learn about the data type and all, then we'll come back on again to the tables, and we'll then create the tables using the integrity constants and things like that, right? So as of now we are good for today. So if there's no question, we'll meet again tomorrow.
Just a small question.